So something I've had to learn the hard way over the years is wiring. How to connect wires, how to terminate wires, when to use the right terminals, when to use heat shrink, when to use electrical tape, when to use wire loom, what kind of wire loom, and yada, 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 yada. So in this video, I'm gonna go over some of the techniques, some of the things that I personally use to connect wires, some of my things that I have found. Now, with saying that, guys, 100% I guarantee you the way I do things is not how you do things or somebody else does things or how you were taught in a class or not taught in a class or whatever. These are just some of the things that work for me, and I'm going to share those with you. So when you're a mechanic, there is a multitude of different types of wire connections you need to make at one time. Sometimes you need to put two wires together, connect those, and they call those a butt connector, but you need to butt them together. Sometimes you need to put a terminal on them. Sometimes you need to connect bigger wire. Sometimes you need to put really big terminals on it. And you end up having to need a plethora of techniques and tools and supplies at a time in order to take care of every single wiring thing you can come up to. Now, I'm not going to hit every single possible wiring thing that you can imagine because it's just it's unlimited on this stuff, especially when you're a mechanic. When you're doing large cable wires, you can do battery terminals or do battery lugs. There's different kinds of wire loom, all that. So I'm going to start off by showing you guys how to solder two wires together. And this technique, it holds true all the way up until probably about, I'd say, 4-gauge wire. Once you get around 4-gauge wire, this technique doesn't really work. But let me get it set up and I will show you how I end up connecting two small pieces of wire. All right, normally you would have two of the same color wire. Now right now we have a little piece of black wire and white wire. This is probably 16 to 18 gauge. What I like to do is use some strippers like this. These are little Klein tool automatic strippers. They work really good. They have a wire cutter that you can put in through the middle, clip it. Now these work pretty good for cutting wires, and they work excellent at stripping. And I really like these because if you look really close right in there, they actually cut the insulation all the way around the conductor, the actual wire itself, and then they pull them back automatically. So you put it in here. I always start with the largest size that I don't think it is. You can tell that we just stripped back the, we kind of debarked it. So we'll go up here to the 18 gauge, clip it like that. Does them automatically and strips it back. Now I liked these style. I don't like the ones that you see on the infomercials. You used to see on the infomercials. They have two flat teeth, and all they do is they come through and they hit like that, and then it pulls the wire and then it comes out. And the problem with that is when it bites down on your wire and cuts it, strips it out, a lot of times it ends up curling your end of your wire like that. Also, it'll cut into these little strands and it'll pull the strands off, and you'll end up using those automatic strippers. And you'll know them because they look kind of like this. They don't come at them at the side. They come at them in that orientation like that and clamp down and then pull this way. They end up pulling strips of the actual copper out, and then every single one of these little bitty pieces of copper that you end up pulling out, you end up increasing the heat load in your actual wire itself. Now, small wire like this, probably not gonna make that big of a difference, but the wire cutters on these works really good when you have plenty of room for it. But if you don't have plenty of room, then get you some clips like this. If you're working on a vehicle like this Dodge that I'm working on, I'm having to do wiring connections and wiring repair underneath on top of the transmission instead of pulling out the harness. You're gonna need something like these. You know, these Milwaukee universal strippers. They kind of cut the wire, and then you can, as long as you can cut the wire, and as long as your strippers are the right size, then they end up working really, really well. If you have the wrong size strippers, like these go from 18 to 8 gauge, and really they go from 20 to 10 because it's 20 to 10 over here, and then 18 to 8 over here. But if you get the wrong size and you're trying to strip the wrong size wire, then you end up having to work too hard at it, and when you pull the actual wire, it ends up pulling the wire out of whatever you did. And I've done that before. So we're going to work on soldering it right now. To solder two wires together, you need to have about I'd like to say about an inch and a quarter, about that much. Now you can tell that the wire is all, this is called stranded wire. Automotive wire is going to be stranded. Household is going to be solid. Do not mix the two. I have used stranded wire in household and not thought twice about it, but solid copper wire is not very friendly with vibration, and it'll end up cracking and bending, because the problem with copper is it ends up flexing back and forth, and wherever that joint is where it flexes back and forth, it work hardens, and when it work hardens, it gets really brittle. If you guys have ever grabbed a piece of wire and it is just absolutely stiff, and like you really have to, it feels like if you bend it, it's going to break. It's because it's gotten hot and it's work hardened. Now it's a hardened piece of copper. So you stranded, you can tell if you look really, really close, this wire has a twist to it when they braided this wire together. It's not just stuck in here. They don't just grab a whole bunch of strands, lay them down flat, and then shove them through the copper, or shove them through the insulator, this plastic stuff. They actually twist them like that. So right before you're going to, and this holds true whether you're going to solder it or whether you're going to butt connector it or anything, you need to twist the wire together to kind of hold them together like that. So we'll do the same one on this side, and it doesn't have to be super precise as far as your measurements, as long as they're roughly the same side. So we're going to do a solder connection on this. One, make sure your hands are pretty clean. They don't have to be absolutely surgical clean, but you don't want a bunch of grease and dirt and grime working around. So if you've been working underneath the vehicle, wear some gloves or go clean your hands before you do this, because you get dirt and oils on your copper, then try to solder them together. Well, that dirt and oil covers the copper, and the solder doesn't end up sticking to it sometimes. There's two different ways to do this. The way I like to do it is you make an X like this, put your thumbs on here, and then twist it. Some guys, and for this video, I'm going to do it this way. If you bend this guy over at a 90 degree, and you bend this guy over at a 90 degree, you hook them like that to where they make that connection, or that style, and then you wrap both sides as tight as you can around each other. Use your fingers to make sure that the little frayed end are sticking down, because when you use heat shrink over this connection, you don't want those little bitty pieces of copper sticking straight up. So that's a pretty good connection. I could have went a little shorter. Actually, I could have put them together a little closer, but for sake of the video, I'm going to go ahead and rock this so we can see the solder connection. Also, don't be super concerned about if you went too long. Just make a mental note on the next one that you do that you need to make that bend a little shorter so you don't have this extra space right here. Now, something I like to do, especially when I'm just using, I'm soldering on a bench, is I'll grab a little alligator clip just like this. These are really cheap. You can get them on Amazon. Of course, there'll be a link in the description. Just like everything in this video, like these Klein pliers, these Milwaukee pliers, even this really kick-ass vise that I have. It's really neat. It's got a little table clamp right there. Clamps to the edge of any table. It's got a handle on the side that you unlock and allows this guy to move around, rotate, get in any kind of position, and then you lock it back, and then it's there. It's locked on the spot that you left it on. I've had this vise for a long time, and it's worked really, really well for little soldering projects like this. So in order to hold one side of the wire, I use an alligator clip, and then I stick the alligator clip in the actual vise itself and hold that. And that way it makes it a really easy way to where I can make an adjustment real quick, and I don't have to use the actual vise. So then we're going to take some electrical solder. Already got my soldering iron fired up. Want to wait until your soldering iron is hot enough to melt the actual solder that you selected. Now, there is a difference between solders. There's rosin core solder, there's electrical solder, there's acid core solder. Acid core is for plumbing, like copper pipe plumbing for your house, water stuff. Rosin core can be for electrical. I use it for larger connections. Smaller wiring like this, I usually use just silver solder. Silver solder is also used for circuitry, circuit boards. So I need to clean the tip of my soldering iron off. You can tell it's all black and everything. So I'm just going to grab some Scotch-Brite pad and then try to get all that black stuff off. And again, we just got to wait for the soldering iron to get hot. I wish I would have plugged this dude in earlier. You can use rosin core on this and it's fine, or you can use silver solder. I think silver solder works a little better, but for demonstration purposes, but for this one, we'll go ahead and try to use this rosin core. Rosin core actually has rosin inside the middle of this solder, and when you heat it up, it adds kind of a flux to the copper wire and helps it wick in and adhere better. So when you first start off, you need to tin your soldering iron, which basically just means add some solder to the end of it, make the end shiny. Now we've tinned the end of the solder. Now what I like to do, the way I was taught was to put the soldering iron on the bottom, put your solder on top, and then heat up the copper. I prefer to actually put solder onto the soldering iron until it has a big little droplet on it, and then hold that to the copper, and then stick the solder into the, or stick the solder on the copper wire. I think it works better because I think sometimes when you do this way, where you just touch it and you wait for it to heat up, it takes too long to heat all the copper wire up, and then the insulation starts cooking. So what I do is I touch the soldering iron straight to the actual, make sure we get a big old glob of solder built up. And once we have that glob up, then I come to the bottom. So as soon as we have that glob, I keep feeding solder in until I get a big glob like that, and then you run it back and forth until the solder is on there. But you need to hold it on, and you'll see that solder start drawing into the strand. Once it gets hot enough, it'll wick into every single little connection in there, and that's what you're waiting on. You don't want to do a cold solder joint when it just looks like a huge glob mess on the outside. Well, one of my absolute favorite things about making videos and YouTube is camera failures. My battery died in the camera at the very last part of the video that I was making about soldering connections, and I lost about 16 gigabytes worth of video footage. Now I get to refilm it. So anyway, this is what the finished solder joint looks like. I put some heat shrink tubing over it. I'm not going to resolder this because it doesn't really matter for this demonstration, but get you some heat shrink tubing, and you need to make absolutely sure that you have a dual wall adhesive lined heat shrink. This is the stuff you want. It has this adhesive inside that activates once it gets hot, and it seals the entire joint, and it makes a really good connection. So for a connection like this, you need to measure out. It comes in long pieces. You can cut this stuff down to size. So we only need about this much. So we're just going to cut this dude in half. Put that back in there. Slide it over our wire, and then kind of pinch it to see exactly where the wire stops, so you know we're pretty well centered. And you want the edges of the heat shrink itself touching the actual insulator, and a little bit of overlap. And you just take your heat gun, when you start, you want to start in the center on one side, wait till it shrinks down, and then move to the outside on both of them, then and make like a plus pattern. You're going to go on the bottom, top, left, right, and it doesn't matter which way you go. You can start in the bottom and just work your way around, but you need to make sure that you use the heat source on all sides. Now I just use a heat gun. You can use a torch. Torch works just fine, but you do run the risk of burning the wire and splitting the actual heat shrink because you've shrunk it too much. Now, I don't know if this is going to come through on the video or not, but if you can tell, right along the edge, right there, the adhesive is actually poked out of the wire. So on the black part, get right there in that sunlight and that light, you can sort of see this kind of shiny little ridge of adhesive come out. So that adhesive is melted, melted, and then the heat shrink tubing itself shrank down and caused the adhesive to go completely out. So then you have a really, really good, fantastic soldered joint. Now remember, I didn't solder this joint because I just didn't want to have to solder, another one. But once you get done, you give a little tug test, and with that heat shrink on there, I mean, you can really bear down on this stuff and try to pull, and you're not going to pull that wire out. So there'll be a link for this down in the description. I have personally used this particular brand. This is one of the cheapest on Amazon. I think it's like $10 or $15. Get you that set up. It works great. I haven't had any issues out it yet. So that is if you're going to solder your joint. If you're going to put two wires together, solder them, and put heat shrink tubing over them. Now I've actually tried this little set. This is called a solder seal butt connectors, and they work fantastic. I've been using them quite a bit over the last couple of years and not had a single failure. And as long as you do the connection correctly, you won't have any issues with it. So it's got different sizes. You have a white, red, blue, and yellow. Today we're going to be using one of these red guys. And I use the red ones more often than the rest of them, but you can actually get on eBay, you can actually get on Amazon and just buy the red ones if that's your, if you run out. I bought 100 of them from the same company or similar company. But let me get a couple pieces of wire set up real quick and show you guys how to use this little butt connector. So you're going to strip back about 1 inch of wire, and a little less, maybe 3/4 of an inch, about like that. Same thing on our white wire. Now if you don't have access to the other side of the wire, you need to make sure that you take your butt connector and you slide it over your wire. Again, just like on a solder, we're going to twist our wire to make sure that the strands stay together on both sides. And so when you get to this point, again, we're going to do the same thing just like we're soldering, because this solder seal connector has some low temperature, low flow solder right here. So we're going to fold our wires 90 degrees opposed, or bend them rather. And actually I need to strip the wire back a little bit because that's not going to work. All right, let's try that again. So bend these over, that one at 90, that one at 90, wrap them around each other. That's going to give us a very good mechanical hold. And when you're done with that, you take your butt connector, slide it over, making sure that both of these little pieces of red adhesive they have in here are on the actual insulator of the wire, and our solder connection is right in the middle of that joint. Then you take your heat gun and you apply enough heat in the center of this until you see the solder wick into all of those copper strands. Now I hope I can get that on camera, but it's going to be really hard because the closer I zoom in, the grainier the footage gets. Just turn your heat gun on and go to town. And again, you can use a torch with these, but these are a lot more susceptible to using a torch on these solder seal connectors. The connectors, from my experience, are a lot more likely to split from the heat, and they won't split with a heat gun. And there you go. You can tell that the solder is actually wicked all the way up to the insulator on that wire and covered both of the strands on each side. So it's actually in the entire joint, and the heat shrink is shrunk around our wire, and those little pieces of adhesive, that red on each side is adhesive, that seals the whole connection. Then once you're done, you got a really good connection. And when you're using these solder seal connectors, again, it's a solder joint. You have got to wrap the wires around each other like that and then fold them over, because if not, you're only relying on this solder, which is a terrible, it's only meant to be a conductor. It's not meant for any kind of strength. It doesn't provide any strength, doesn't provide any adhesiveness. And you don't want to rely on just the solder and just this piece of plastic, because eventually those two will break down or something will pull on it and then your joint's loose. I've seen other videos and guys when they stick wires in here like that and they just solder them on it. Maybe it works for them, but you know, this is the way that I prefer to do it, is to wrap those wires around each other and rely on a mechanical connection rather than relying on the solder or the tube itself. So there'll be a link down in the description for those. I've been really impressed with them. They're pretty cheap. You can buy an assortment like that, very, very inexpensive. There are some situations when a solder joint's just not going to work. The solder seal connection is not a good idea because you don't want to bring a heat source around certain things, or it's just not practical. And then If you're doing a butt connection, you can come up with these just normal butt connectors. I have a whole kit. You know, I have an entire kit of assortment of these, and they work really well. Now there are different qualities of butt connectors and connections out there. Some of them have built-in heat shrink, some of them don't. The ones that you get at Napa, O'Reilly's, AutoZone, the big auto part box stores, they have this like really cheesy, shiny plastic PVC coating on them, and I've never gotten them to work right. Every time I ever crimp those, that piece of plastic gets cut and split, and they're just piece of crap connectors. I don't know why they sell the ones they do, but they're terrible. And in general, all of the automotive wiring repair that I come across is questionable at best, because the mechanic that did the repair just used what they found at the auto store and they didn't know any better. Now these particular butt connectors, I think they're from Southwire or something like that. I got them from an electrical supply. They're only meant for stranded wire. They're not meant for solid wire, but the type of material they use is really, really good. Generally, you want to find a material that kind of has a see-through material like that. And if you're doing a lot of these, I prefer to have the ones that have the heat shrink on it, but since I switched to these solder silk connectors, I opt for these because just the simplicity of use. Now when you're going to use the actual butt connector itself that doesn't have the heat shrink on it, you're going to have to use a piece of heat shrink over the top of it. So a couple of tips when you're using these. If you look really close, you can see that little bitty round area right there. What that is the way this connector is made. It's a piece of flat steel and they fold it, and there's a little indentation right here, and that keeps the actual wire, once you strip it back, from going all the way over to the other side. When you do crimp these, whatever your preferred crimp tool is, you do not put your crimp, like the nipple, like on this side, you want it opposed to that back, you want it opposed to that little dot on there, like that. So when you actually do crimp it, the nipples are going into the bottom of the connector rather than the top. If you look in there really, really closely, you can see it's dented in the middle to prevent you from actually sticking the wire in too far. And most of these will have a split in the top of them, and so you look inside the end right here, and you see where the actual split is, and then your nipple for your crimp tool needs to go opposed to that split or opposed to that dot. When you make a connection with a butt connector, you don't need as much reveal from the wire itself. You only need about that much, probably about 1/4 of an inch. And so your goal is to have enough wire to where your insulator is not going to hit inside that actual metal barrel. The metal starts right there, and that wire stops right there. So when you insert it, the wire gets fully into that connector. Now before you do this, I have done this 100 freaking times, and I forgot about the heat shrink on it, and I've had to cut freaking connectors back apart because I forgot to put the heat shrink on it. You need to find the heat shrink that just barely fits over your connector, then that's the correct size. Slip your heat shrink over first, then do your butt connector. Only do the butt connection on one side at a time. So we're going to use it like that. All you do is stick your wire in. You got to find the hole. Some of us are better at finding the holes in dark areas than others. And then you just squeeze your crimpers down, and you'll see that little crimp in the back. Now these are not technically the correct crimpers to use for insulated connectors, and I understand that, but I really like these because of the long nipples. Because of the extent and length of the nipples that are on these, they make a superior connection. I don't like the flat style connectors. You can tell, like this one it's got just a really tiny little bitty nipple edge right there, and then those multi ones that you buy at auto parts stores that are like 6-7 inches long, they just don't work very well. You need to get you an actual pair of crimpers, and they sell them at Home Depot, Lowe's, anything like that. There's a link in the description for these Nipix ones. I really love Nipix, and these have been fantastic over the years. So we made our one connection on that side. You need to pull on it to make sure that the butt connector doesn't pull out. Then we get our crimp set up for the next side. The same exact process. You just stick the wire in the hole like that and crimp her down. And now we have a really good butt connector. I've used this style of connector 1,000 times, haven't had any issues with them. The only time you're going to have an issue is if you just put a butt connector and no heat shrink. Then if it's underneath the vehicle, water will get inside this connector and just absolutely corrode it, make it awful. So that's why we get our so that's why we put our heat shrink on there. So you put the heat shrink, slide it over the connector, pinch the ends to make sure that we have an equal amount of heat shrink on each side. And then grab your heat gun or your torch or whatever your preference is. And there you go. On this larger butt connector, you can see the little shiny area, that adhesive actually poking out of there, a little clearer than that smaller connection. And I'll show you guys what happens if you hit this with a torch. If you get it too hot, you'll split it. You can tell I've already cooked it, and now there's no, it's not sealed in any way, shape, or form, and you can tell where it's all bubbled up, and it's not a very good connection. Same thing on the solder seal connection. If you get these too hot with a torch, you'll overheat them. And that'll happen. And that's an extreme version of this, but I have had it happen sometimes when I'm trying to get that solder to flow, and then the rest of it ends up melting. So I highly encourage you guys to get a heat gun. If you don't have one, as a mechanic, you're going to need one. They're an invaluable tool. And of course, there'll be a link in the description. So I've showed you guys how to do a solder butt connection. I've showed you guys how to use a solder seal butt connector. I showed you guys how to use an actual, just a crimp style butt connector with heat shrink. And there's a couple of other ways to terminate wires on the end. In my kit, I have some different terminals. They call this one a ring style terminal. There are spade connectors. Seems like everybody has their own preference what they call them. This is like a little spade. There's a little hook that I really like to look like that. These are fantastic for anything that has a bus bar on it with a screw. You just loosen the screw and you hook that around it and then tighten your screw down, instead of a ring terminal where you have to take your screw all the way out, stick your screw through the hole, hold it with a Phillips screwdriver, get it lined up, and then tighten it down. So if you guys are installing radio stuff like amplifiers, these are really good to have. These also have the heat shrink built into the end of them. Now, the only issue with these is that, again, the way they make them, it's a flat piece of steel, and if you can look inside there, you can see that little bitty line right there, and that's where they actually folded the ends together. You can see it better on here on the top, right there. So when you're crimping these, again, whatever crimp you're going to use, you need to crimp the bottom of it, is where your nipples go. So the nipples need to be opposed 180 degrees from where that line is. That way, whenever you're actually tightening it down, it bends the bottom up into the connector. Then that'll give you their space for your wire. If you do the other side, to where the nipple goes on top, you won't ever get a very good connection, and it actually will break the edges on it. And you can tell the edges are very, very sharply creased. And most of the time, at least from my experience, you won't be able to get directly right on top of that where those two pieces meet, and it'll kind of get off kilter a little bit, and you'll be able to pull your wire out. And with these connectors, there's a bunch of different styles out there. You've got little Spade connectors. You've got these ones that are little weatherproof connectors to where this side marries into the male side marries into a female side, and they slip together to make a really good connection. But you got all sorts of different terminals, butt connectors, spades, different size ring terminals, different size spades. So you end up just having to have kind of a good assortment on hand all the time to suit all your needs. Now the other style connector we haven't gone over yet is an open barrel connector for a pin. So weather packs, Deutsch connectors, Ampsil or Ampfil, I think it's Ampsil. They all have removable pins, and every vehicle that you ever work on is going to have a harness that has a pin on it. And if you specialize in one area like Ford, or you're working on Volkswagens or BMWs, you need to figure out exactly what type of terminals they use most of the time and get you the proper crimper for that. This one is a Deutsch style connect. You put the terminal on your wire, and then you stick it in through the back, and then you have like a little weatherproof connector. I'm not going to show you how to insert it and everything, but I will show you how to put a wire on this. So when you're using these, you're not going to have a very long stick out, because if you have too much of a stick out or too much of a reveal, the wire actually gets in the way. And you stick that guy on there like that, but you can't use just a normal style of connector for it. So we call these a ratcheting style. They work pretty well. Every single connector out there has a particular type of crimp that it needs. These have replacement jaws, and you just stick one jaw in like that, stick the other jaw in at the bottom. These have two different sizes in for the connector. When you put your connector in, the larger side goes, when you put your connector in, the smaller side goes to the smaller one, and the larger size is the one that crimps on to the actual insulator. So these can be pretty challenging to do, because you have a bunch of different things going on. You need to hold the wire, hold the terminal, and then put it all together. So you grab your connector, you push it down into the holder just a little bit, and that should give you enough retention to put your wire in, and hopefully don't knock it out of the dang thing. So then all you do is come over, clip it like that, and hopefully you did it right and you end up with a pretty good joint. Now that's not perfect. Actually, I didn't get I chose the wrong size first. I should have done this size instead of this one. But you end up with your pin on a brand new piece of wire, and you give it the old tug test, and you got a good connection. And so that's how you use the ratcheting style ones. A lot of guys like the ratcheting style ones for butt connectors. I don't really prefer them, but you know, at the end of the day, you'll end up using and developing your own techniques for wiring connections, wiring repair, and you end up stealing a little bit from one person's ideas and creating your own and making your own technique. Now, that's all the smaller connection stuff. What do we do about the larger wires? What do we do about battery cables and battery ends and things that require a lot of amps through them? Well, for battery cable ends, and I don't have any on hand, you would actually buy a battery terminal from like Napa, or order them online or anything. And the sky's the limit for, you know, how much you want to spend on them. The ones I like to use are the solder top connections. Some guys like to use the solder top connections in a hammer style. It's a little clamp deal that you stick the wire in the terminal in, you smack the holy hell out of it with a hammer, and it indents it. I hate that style. I don't think it's meant for big thick wires or battery cables, but you know, to each their own. What I like to use is just a regular battery terminal that's a solder top style. You fill the end up with solder with your torch, and then you dip your end. If I had some battery cable, I would show you, but the best thing I have to show you is the same exact process, is this 4-gauge battery cable. Now, I'm going to show you on this little lug kit. If you guys are into diesel work or industrial work, commercial work, or heavy equipment, you have got to get this freaking kit. This is a extremely good kit. The quality is excellent. I was very, very shocked. Again, it's a very inexpensive kit. You would think that it's absolute crap, but it has worked tremendously well. So I'm going to show you guys my technique for a 4 gauge. This is a 3/8 ring, and show you on this positive cable. It's a really easy technique. You don't need much. All you need is, I prefer to have a razor blade on hand. If you don't have a razor blade, your handy knife. But you take your terminal, you figure out exactly how far in the wires are gonna go. You mark back maybe about a 1/16 of an inch farther than that. And then you take your knife or your razor blade and then you cut the insulation off your wire. Again, we're still twisting the wire together, and that keeps all the actual wires together themselves. Then we're gonna dry fit our connector to make sure, one, we've got the right size connector. Take your new connector and slide it on. And if you run into your insulation, then you don't have enough wire out, so you need to cut off just a little more. Okay, now you can tell we had the right amount, because when we put our connector on there, there's just a little bit of reveal left on there. Just a small, tiny little gap, and that's gonna let our solder come out from the gap. All right, to make this connection, you don't have to have a vise. I use vise grips out in the field 100% of the time. They work absolutely perfect. If the entire cable is off the truck, then I'll use the vise in my truck. But make sure that you put your heat shrink tubing over the wire itself before you start this process. And all we're going to do is grab our torch, heat this lug terminal up, stick solder in here, and we're going to put as much solder in here to fill it all the way up until about a 1/4 inch from the top. So once we get our solder in it, we're going to heat it back up. You're going to grab your wire and you're just going to plunge it in. So it's all the way settled down. Let it cool off. Now, something else I like to do in situations when you're doing it on the vehicle is I get a wet rag and then put it around here right when you get done, and then just douse it over that entire area to help cool it off so you can get to work quicker. Once you let it sit for a couple of seconds, then we're good. Then all we have to do at this point, slide our heat shrink over it. On this thicker heat shrink, you can just use a torch, works fine. Just like that, now we've got a professionally installed lug. And you want to use rosin core for these large lugs, because rosin core is going to add that flux to it that's going to help adhere to the copper wire and the cable, as well as the copper in the lug itself. And I have used that style of connection on, again, battery terminal ends, marine top terminal ends, these battery lugs. Any large cable, I've used that. Now, I know I've read in the comments before when I made a video about installing battery lugs, like, oh, if you don't heat up the copper on the wire, then the solder doesn't. Bigger wire, you've got so much heat built up into your actual copper and the solder itself. And when you stick the wire down in there and you keep the torch on the bottom, it's enough heat to wick that solder in it. If I were to cut this joint off, you'd see 100% solder flow into the actual copper itself. I've been fine, and I've never had a failure. It's whichever one you want to do. If you want to take the torch and you want to heat up the stranded wire, be my guest. In my opinion, stranded wire like this, if you take a torch to it, you're going to overheat the outside of the shell of the actual wires. You're going to heat those up way too hot. They're going to get red hot. Then you're going to have problems on the outside of it. You're also going to start melting your insulation and everything. So it's just and from my experience, it's just not an issue just to fill up the terminal full of solder. Now, you do need to make sure that the terminals that you get are not crimp style terminals, because crimp style terminals oftentimes have a little hole right here, and when you're putting solder in, it'll start building up, and then all your solder will end up flowing out because there's a hole in it. Now, the other thing I want to talk about is wire loom. There's two different types of wire loom. There's split loom, which is this style. And then there's this woven type loom. Kind of looks like a snake. Now this woven style loom is my preference. I love this stuff, but you can only put this stuff on when if it'll fit over the actual connector itself, which is most of the time. But if you have a large connector like this, it's just not going to fit. So you have to be cognizant when you're building the wiring to go ahead, put your woven loom over it, and it installs really, really easy. You just stick your wire through it like that. You feed it on, and it is time consuming, but to me it's a superior setup. This stuff doesn't get UV baked and doesn't get to where the point where it just flakes off because of heat. It always stays on there, and it just looks a little more professional. Now when you do get to the end of this, you see how it's all stranded out like that? What I like to do, get some electrical tape, wrap it around here, cut off all your ends, and then you put your... So when you get to the end, you have that little setup like that, and all you have to do to get rid of those frays is get you a really sharp knife or a pair of dikes or something, which these are not very sharp. Cut them like that, feed it through the wire, or feed the wire through the loom rather, and then when you actually make your connection, so you put your heat shrink over, make sure your wire is tight, exactly where you want it. Your wire would meet your terminal right about here, and then you would stick the heat shrink over both of those, heat it up, and that would actually make a very, very nice joint to where you've got your wire loom on it, and it looks very, very professional. I love this style of wire loom. It works really well. It stays tight to the wire. It can rub on anything metal, and it's not gonna fray apart. And it doesn't disintegrate like split loom does. So this is split loom, and they call it split loom because it's got a slit down the middle of it to where it's very easy. You can put this on existing wiring. Now sometimes you're not in a position, like you're underneath the car and there's existing wiring harness and you're not going to clip the terminals off or deep pin connectors and anything. So you put your split loom on like that, and you work it all the way down. Now in split loom, again, my preferred method to terminate it is to take a piece of heat shrink tubing, put it over the end, melt it down, and that clamps the end of it to the wire and kind of adheres it to the wire to where you don't have to worry about it at all. And it works really, really good. If that's not an option, you can't put heat shrink on it. It's something I learned to do. Just take some electrical tape, start by wrapping it around the wire a couple of times. Take your split loom and run that slit around your electrical tape like that. And then you run your electrical tape on the end to make sure that you end up with electrical tape on the actual wire itself and on the end, and that'll hold it and make it really good. Now the problem I hate about this split loom is it seems like all the split loom I've ever used is a cheap piece of crap, and once it gets hot, it just absolutely disintegrates and just does not do the job it was intended to do in any way, shape, or form. If you run it up underneath the hood, this stuff after a couple of years, or in a year in Texas, will just completely disintegrate and not help you at all. I really like this stuff. It's cheap, comes in various different sizes. There'll be a link down in the description for it. Well, that's my wiring tip video. I hope you guys enjoyed the video. Put your own tips down in the description. Again, I cannot emphasize this enough, guys. I am not a wiring expert. There are no such thing as wiring experts out there. There are people that do a really good job, but one particular technique will not work 100% of the time. You have got to try every technique that I just showed you. Watch some other guys' videos, try their techniques, and figure out what works best for you. What you feel like is the superior way to connect two wires together. Now there are some do's and don'ts. I can guarantee you 100%, I'm gonna have guys in the comments say that fraying wires together and sticking them like this and folding them down, or doing a Jack and Jill method, or all this other nonsense when it comes to soldering two wires together. Oh, this is the superior because blah, blah, blah. And they're all wrong. The only correct way to connect two wires together is to fold them over and then wrap them around each other in opposite, counterclockwise, clockwise fashion to make a mechanical joint on it and then solder it together. Other than that, every single thing that I showed you here, there's other tools out there that you might prefer, you might found that work better. If so, put it down in the comments, let us know. I hope this teaches you a little bit about wiring and what to expect when you're wiring, especially when it comes to automotive mechanic and diesel mechanic and industrial mechanical, commercial mechanicking, marine mechanics, and heavy equipment mechanics. We share a lot of this exact same type of wiring. When it comes to automotive wiring, I don't know what the deal is, but you find some of the most absolute shoddy wiring jobs you can possibly freaking imagine. And I think it's mainly because AutoZone, O'Reilly's, all these, big box auto part stores, they have the absolute crappiest quality terminals, connectors, and anything because they're buying them in bulk. So they get, a box of 100 for 10 bucks and people think they're getting a really good deal, but you're getting a guaranteed box piece of crap. I don't know why they don't have better connectors. Napa seems to have a little bit better quality connectors sometimes, but even then it's getting kind of a crapshoot. People are just, they're stocking the cheapest junk they possibly can get away with and selling, and then automotive wire becomes the outcome of that. You hardly ever see that stuff in 18-wheeler shops. I can guarantee you never see I can guarantee you never see that kind of nonsense in oil-filled stuff. Oil field generally uses marine grade or aircraft grade, aerospace grade stuff. All that stuff is better quality. Do your research and find good quality. I have links in the description for all of this stuff, for the battery lug kits. I'll have links down there for the actual solder on battery terminals. Those are good to keep in your toolbox. I have links for this wire loom. I have links for the Milwaukee strippers. I really like these, and one of my favorite things about them is you can find them at most Home Depot, Lowe's, whoever sells Milwaukee. These Nipix, I believe these are non-insulated, closed barrel terminal crimpers. These have worked fantastic for me for all sorts of things. I like to use them for things they're not intended to use them for. Hands down, one of my absolute favorite wiring tools ever are these automatic strippers. This style, not the other style. I have a pair of Blue Point strippers. These are kind of a joke at best. I wouldn't get these from Snap-on. I think they're kind of shitty. The terminal kit that I have, I'll put down there in the description, and as well as a dual wall adhesive lined heat shrink assortment. I'll keep them in the description. If you guys click on any of those links and you order them, they're all Amazon affiliate links. I get a very small percentage of that sale. It's 5 to 7% of the sale that goes directly to me. I really appreciate it. It does not mark your product up. So if you buy $100 worth of stuff, it is $100, and I get $5 to $7 out of the sale. That comes out of Amazon's pocket and out of the seller's pocket. It does not come out of your pocket. Also, if you click that link and you go over to Amazon, even if you don't buy any of this stuff and you decide to purchase anything else, I still get 5 to 7% of that sale, and I really, really appreciate it. It helps me out, and it's one of my favorite ways to make money off these videos, because you guys get to buy a product that you were already going to buy or wanting to buy or decided to buy. It doesn't cost you a freaking dime, and I end up getting paid for it. It's a win-win for both of us, and like I said, I really appreciate it. So guys, please let me know down in the description your tips, techniques, and tricks for wiring that has worked for you. If you think I left something out, please add it down in the comments or link other videos and show guys, because I want this video to where a guy will watch it, learn about this, pick up some tips, and go in the comments and be able to pick up a lot more tips to have that whole arsenal of information and tools and knowledge at his disposal, to where when he comes up to a wiring situation, he knows exactly what type of wiring and what type of terminal. Should it be soldered? Should it not be soldered? Should we use open barrel? Should we use closed barrel? And all that other stuff. Appreciate it, guys. Hit the like button, hit the subscribe button, and get out and fix it.